So what do we do?
Okay.
What would you like to work on today?
Right now it's sum and difference identities to find. So that's pretty much what we're doing right now, sum and difference.
There's a reason for starting with this one. You would think you would start with sine, but cosine is actually a little bit easier to remember. Do you know what this is?
I have no idea.
Each one of these is going to have two cosines and two sines. This one has both cosines in front, which means it has to be cosine A, cosine B. And then the sine is the opposite of this sine. So it's minus plus. And then the next two terms have to be sine. So it has to be sine A, sine B. Now, let's go over the sine one, and I'll show you why the first one is easier to actually remember.
Okay.
For the sine sum and difference, first of all, the main thing I remember is that the signs don't change. They're not opposite. So they're plus minus in the middle. Second thing is that I know it also has two sines and two cosines in it. Only it's sine cosine, sine cosine. And it's sine of A, cosine of the other angle, B, plus or minus, and then the opposite. And the only opposite you could get would be sine of B, cosine of A.
Okay.
So those are your two primary formulas, and then you can work out tangent. Tangent is sine over cosine. So tangent, there's an identity for that also. It's not as important as cosine and sine. So let's just do an example. What would the cosine, and we'll use radians. You do most stuff in radians now, do you not?
Yep, we have it in degrees and radians. You can do it in different.
So how would I do this? How would I do the cosine of pi over 3 radians plus pi over 6?
Would I look at the unit circle?
Well, no. Look at this.
So the cosine A times the cosine B.
So cosine of what?
Pi over 3 times the cosine of pi over 6.
And then what?
Then plus or minus.
Hold on. If it's a plus here, then it's a minus there.
Okay.
If it's a minus here, then it's a plus here. So whatever this sign is, this is the opposite. So it has to be minus. Now what's the rest of it?
And then sine B times
Sine of pi over 3, sine of pi over 6. Now let's go through what those are. What's cosine of pi over 3?
Thinking about it, I think it's 90. 90 in radians.
Let's go over radians. The three most important ones you can remember are these three.
Okay.
That's equal to 60 degrees. That's equal to 30 degrees. And that's equal to 45 degrees. Notice in every one of those multiply to 180. The magic number in geometry and trig is 180. Okay? So whenever you're converting pi over like 3, it's got to be 60. Well, if I have 2 pi over 3, then it's 2 times 60. So that would be 120. But as long as you memorize these first three, you'll be fine. Just always know what those are. And, you can use the conversion ratio. In other words, if I multiply that by pi, or 180 over pi, I get 60 degrees. Same thing,
Okay.
if I multiply this by 180 over pi, I get 30. But you don't always have to take the hard method. That's kind of the hard method, is multiplying by the conversion factor. The easy method is, as long as it's just pi in your numerator, then the conversion is always a number that times that is 180. And that makes it quite a bit easier to remember.
Okay.
So, cosine of pi over 3 is the same as cosine of 60 degrees. The other triangle that it's extremely helpful to have memorized is this one. It's what I call my unit special triangle. In other words, as long as you know this triangle here, you can do these, all four of these. What's cosine of 60 degrees? Based on
1 over 2.
Based on this triangle, and so the what?
1 over 2.
What's cosine of pi over 6?
That would be root 3 over 2.
And what's sine of pi over 3?
Root 3 over 2.
And what's sine of pi over 6?
1 over 2.
So this answer is what? What is the cosine of pi over 3 plus pi over 6?
Cosine of pi over 3 and then pi over 6. Wouldn't I have to multiply them at some point?
Well, they look the same, so my answer should be 0. But I did something wrong. I'm not sure what. Let's see. What could I have done wrong? The sine of pi over 3 plus pi. That's actually correct. Notice what that angle is. What's pi over 3 plus pi over 6? Add those two things together.
2 pi over 9.
You got to find a common denominator, but the common denominator is 6. So this becomes 2 pi over 6 plus pi over 6 is 3 pi over 6, which is pi over 2. So that angle that I called pi over 3 plus pi over 6 is the same as pi over 2. And what do we know the cosine of 90 degrees to be?
0.
And that's what you get when you do it this way also. 1/2 times root 3 over 2 minus 1/2 times root 3 over 2 is 0. Okay? The two triangles that are most important, if you memorize these two triangles and their dimensions, then you will pretty much know all trig functions in the first quadrant. And that's a huge step. If you know all your trig functions in the first quadrant, then you can apply rather simple formulas to figure out second, third, and fourth quadrant. But the absolute vital thing is that you memorize your trig functions in the first quadrant. By that I mean 30, 45, 60, and actually 0 and 90.
Okay.
Okay? So the one thing that will, if you just memorize that picture that you see, that I'm outlining, you will always be able to figure out your trig functions in the first quadrant. What is the sine of 45 degrees?
So I could use a thing that's circled and figure that out? Oh, never mind. I get it. Okay, SOHCAHTOA. So opposite over hypotenuse, 1 over root 2.
Correct. What's the sine of 60 degrees?
So that would be root 3 over 2.
Correct. In other words, these two triangles will answer all 6. What's the tangent of 45 degrees?
SOHCAHTOA. It's the opposite over adjacent. 1 over 1.
Right. Now, I
So
heard an interesting thing about trig once, and I believe it 100%. You don't want to memorize trig functions. You want to know them like you know your name. In other words,
okay.
You don't have to memorize your name. If somebody says, "What's your name?" you instantly know it's Taylor. You don't have to wait for a second, locate the spot in your brain where Taylor is memorized, and give it. So there's a difference between memorizing something and knowing it. And you want to get good enough, especially if you're taking this trig course, that you know trig. It's like a foreign language. It really is. If you were learning Greek or Chinese or something, you would want to get to the point where you can think in Chinese instead of always translating. When you always have to translate, it slows you down just a hair. So you don't want to have to think SOHCAHTOA every time I say sine, cosine, or tangent. You want to get to a point where you know exactly that tangent is that over that of 45 degrees, or tangent of 30 is that over that, or cotangent is the reverse, this over that. Makes trig a whole lot easier if you can get to that point. All right. Now, notice what I did here. I just randomly picked out a couple of angles, and it happened to be pi over 2. But where it's particularly useful is if I said, what is the cosine of this? Well, without a calculator, I mean, assuming we can't, you can do all trig functions in a calculator. Okay? I mean, when I went to high school, we had to use a textbook, and they had tables in the back. And that's where you got your trig functions from. But this is not a 30, 45, 60, 90, or any of those common ones. So this angle, I don't know right off the get-go what the cosine of that angle is. I don't have any reference triangles that I can access. Okay? But if I know that 7 pi over 12 is the same as pi over 3 plus pi over 4, which it is, I can use my sum and difference identities using all angles that I know. What's this going to be equal to? What's the sum and difference for cosine? Taylor, you still there, or did I lose you? Taylor? Taylor?
You have reached the voicemail box of 9.
Taylor?
Hello?
Yeah, hi, boy.
Okay.
Okay.
Sounds like we had some computer problems.
Yeah, I have to use my mom's computer now.
Yeah, I can tell. Okay, that's the one problem with online tutoring is that every now and then technology gets in the way. I wanted to say something else about why sum and difference even matter. Well, if I said, what is the cosine of 7 pi over 12? You wouldn't really know that answer. You don't have any two reference triangles that'll give you that answer. But if you know that 7 pi over 12 is the same as pi over 3 plus pi over 4, now you know the answer to cosine of pi over 3 and cosine of pi over 4. Whereas you don't know the answer to cosine of 7 pi over 12, but you can now find it out. In other words, if you can put together two angles that you know the trig function of, then you can figure out the trig function of odd angles. So what would this be? How would I write this? What's the cosine of pi over 3 plus pi over 4? Let's write it in generic form first. So the first term's cosine of what?
Cosine A.
Well, by generic form, I mean go ahead and fill in what A is.
Oh, then pi over 3
Okay, what goes next?
times cosine pi over 4.
What goes next?
Plus.
No, it's always opposite.
Yeah, it's a minus. It's always opposite. Okay.
Right.
So then minus
And this has to be what? Which trig functions?
sine.
Sine, sine. And once you know that it has to be sine, sine, it can only be this. So I'm a firm believer in memorizing as little as possible when you memorize stuff. The only part of this you really have to memorize is that part. And the fact that you know there's going to be two cosines and two sines in the answer. Okay?
Okay.
So, what's cosine of pi over 3? That's, which angle is that?
That would be 60.
Okay, cosine of 60 is?
Cosine of 60 is 1 over 2.
Cosine of what angle is that?
Say that again? Oh, pi over 4.
What angle?
That would be 45.
Okay, what's cosine of 45 degrees?
Root 2 over 2.
What's the sine of 60?
1 over 2.
No, that's the sine of 30.
Never mind. It's root 3 over 2.
And the sine of 45, same as the cosine of 45.
Root 2 over 2.
So there's your answer. I mean, we have to do some algebra. So it's root 2 over 4 minus root 6 over 4. So there's the answer for the cosine of that angle, which happens to be 105 degrees. In other words, it's an odd angle. So sometimes you can figure out odd angles by using the sum and difference form. Did you have any specific problems? I mean, I kind of have monopolized the conversation here. Did you have any you wanted to do?
I have one right here.
Okay.
So this one is. I'm trying to find one that I don't know at all. I think. How about cosine 160 degrees?
Okay. Notice
times
that
cosine 40.
Times what?
Cosine 40 degrees. Plus sine 160 times sine 40.
Okay, so this one, they're kind of giving it to you in an odd way. In other words, they're giving you the right side of the equation, right?
Yes.
In other words, if the cosine of A plus or minus B equals cosine A cosine B minus or plus sine A sine B, they've given us this. So what is that the same as? Cosine of what? In other words, this is the information we have. That's the right side of the equation. What?
So cosine 160 times cosine of 40?
Not times. Remember, this is sum and difference formulas. So it's always got to be added or subtracted.
Then I add it.
Remember that the cosine is opposite in the middle. This
So
has
then
to be 160 minus 40. In other words, if I ask you what the cosine of 160 minus 40 would be, you would say the cosine of 160 times the cosine of 40 plus, in other words, to make that sign opposite, the sine of 160 sine of 40. Well, we don't happen to know any of these. I don't know what the cosine of 160 or 40 is. But I do know what the cosine of 120 is. Because that's a multiple of 36. What is that?
Negative 1 over 2.
Right. In other words, that's the same. The first the way I do the unit circle is I always figure out what the first quadrant angle would be. And the first quadrant angle would be 60 degrees. Cosine of 60 is 1/2. But then I figure out what the plus or minus sign is in the second quadrant, which is where 120 degrees is. And cosine is negative in the second quadrant.
Okay.
Okay. So are you on the unit circle yet? You must be beyond the unit circle.
Yes, yes.
To be in sum and difference. Yeah. Okay. Well, it was a decent session. We only did cosine, but sine is basically the same thing, only a different formula. You know, as long as you can remember what the sine formula is, then you're doing the same process.
Okay. No, we haven't done sine in class yet, but we can do that tomorrow.
Okay, Taylor. I will talk to you at 3 o'clock tomorrow, right?
Yep.
Sounds good.
Okay.
Talk to you.
Sounds good.
Bye-bye.